Hello everyone, my name is Emanuele Giuseppe Esposito, and in this demo I will show you how to retrieve secrets from a confidential container using the Trustee operator on Azure. Let's first start with the setup. Using the Openshift Sandboxed Containers and the peer-pods technology, we are able to create a confidential container. From the Openshift perspective, a confidential container is a normal container, but instead it is not running on the worker node. It is running on an Azure confidential virtual machine. A confidential virtual machine is equipped with the hardware trusted execution environment, which provide memory encryption. The main components inside a peer-pods confidential virtual machine are the Trustee agents. These are used to connect with the Trustee operator to perform attestation. And then we have, of course, our pod that runs inside the Azure confidential virtual machine. But the twist here is that the logic inside the pod, the workload, is encrypted. But where is the key? The key is not yet present inside our confidential container because we do not yet trust the confidential virtual machine and the hardware and the software running inside of it. That's why we need to perform attestation. Attestation is performed using the Trustee operator. The Trustee is running in a user-secure environment that could also be a separate OpenShift cluster. It is composed by the key broker service and the attestation service. Let's see how it works. The Trustee agents first connect with the hardware trusted execution environment to generate a platform report. This contains all the measurements of the software and hardware inside the confidential virtual machine. They are then sent to the key broker service, which forwards them to the attestation service and compares with the reference values that is inside. If the measurements match what we are expecting, then the attestation service provides the key to the key broker service, which is then sent to the Trustee agents. The pod has then the logic to fetch this key, decrypt the workload, and run the workload. Let's look at the practical demo. Let's start with the Trustee. In this cluster, we just installed the Trustee operator. As you can see, there is the Trustee deployment that is up and running. Inside the Trustee, we just added a secret, which is called the workload key. And inside the secret, there is a file called key.bin. This is the key to decrypt the workload. If we look at the KBS config, we can also see that the secret resources contains this workload key. Let's now look how a confidential container actually retrieves a secret. Let's look first inside the pod logic. We can see that the pod is called SKR COCO, Secret Key Retrieval, and the machine type in Azure terminology is standard DC2AS. I will show you later what this actually means. The command that is run inside the pod is simply a slip because we are running command live inside the pod. If we look at the Azure documentation, we can see that the DC-AS v5 series are confidential virtual machines. Let's now check our OpenShift cluster. We can see that SKR COCO pod is already up and running. We can also see that it is a confidential container by going into the Azure Web UI under virtual machine and see that in addition to the master and the worker nodes, which are the OpenShift clusters, there is also an additional pod VM SKR COCO VM. This is where the SKR COCO pod is running. The machine type for this instance is standard DC2AS v5, which, as I showed before, is a confidential virtual machine. On a separate terminal, we are also logging the Trustee deployment logs. We can see here how attestation works from the Trustee side. Let's now go inside the SKR COCO pod and perform attestation to decrypt a workload. So we go into the work folder and we can see there is only two files, the fence program to encrypt and decrypt files and the workload. The workload at the moment is encrypted. In fact, if we try to run it, we can see that it cannot be run because it's encrypted. Now let's perform attestation. We try to get the key and we try to first contact the trustee agents, which are inside the confidential virtual machine. That's why we are pinging localhost. We are asking for the workload key, which is the secret I showed before inside the trustee, and we are asking for the key.ping. Let's run the command, and we can see that we got a key. If we look inside the key, we can see it's actually keys, and from the trustee logs, we can see something happen. The authorization API has been called, the policy checked as passed, and the resource access request passes the policy check. That's why it returned a key. Now that we have our key, we can call the fence program to perform a decryption operation using the key on the workload. We can see the file was decrypted successfully. Now we have a decrypted file here. Now let's run the file. We first make it runnable, and then we run it. And we can see the workload is running. And now let's say a case where attestation fails. In this case, we are not running a confidential container, but a simple container that tries to connect anyways to the trustee operator and perform attestation. And we will see that it will fail because it's not running in a confidential setup. Let's look at the pod logic. The name of the pod is SKR kata, and the machine type is standard D2AS v5. Notice there is not the C because it's a different machine type. The technology is still the same. We're using kata remote, which means we are using peer pods. And the command is also the same. We are sleeping, which means that we are still running in a peer pod virtual machine that has the trustee agents that they will connect to the trustee operator. But the attestation in this case will fail. As we can see from the documentation, the ASV5 series are not confidential virtual machines. Inside our Openshift cluster, we can see that the SKR kata pod is already up and running. We can also show that this pod is running in a peer pod virtual machine, which is not a peer pod confidential virtual machine. The main difference here is that there is no hardware trusted execution environment, which means that the memory is not encrypted. If we go to the Azure Web UI under virtual machines, we can see that we have the master and the worker nodes from Openshift cluster, but we also have the pod VM SKR kata, which the machine type for this instance is standard D2ASV5, which, as I showed before, is not a confidential virtual machine. On a separate tab, we also are logging the trustee deployment to see what is happening with the attestation. Let's go inside this pod and perform the same workload as before. So we go into work folder. We can see there is the fence program and the workload. The workload is encrypted, and we can see we cannot run it. Let's perform attestation. This time we get a key and we put it in a file called key.ping. The process is always the same. We ask the trustee agents to get the workload key secret, more specifically the file called key.ping. We see that we have a key, but let's inspect it. We can see there is no content as I showed before, but instead there is an error. Let's look inside the trustee agent what happened. We can see there are a lot of logs, but the main one is this one, resource not permitted, which means the attestation failed. And this is why we cannot fetch the key. In fact, if we try to perform the fence program to decrypt the workload with the key that we just got, we can see there is invalid key sites and the whole process fails. This concludes our demo. Thank you and goodbye.